Hello and welcome back to NTMAU. This is Ken McCrate and I'm going to go over this problem. The key to this problem, to solving this problem, is finding right angle triangles. And another thing that's going to help you is that you use the calculator that's in your computer. Most standard PCs have this calculator if you have Microsoft Windows. And if you don't have this calculator that's already loaded into your computer, I know it's the one that we've used pretty much for all the other problems that we've had, but you should have one that has an invert key or a second key. Oftentimes you'll see a second over here, which is going to give you the same thing as an invert key. And then the sine, the cosine, and the tangent. These keys are the ones that we're going to be using primarily in this problem solving. So again, invert key or a second key, which would be here, and sine, cosine, tangent. So you need a scientific calculator. You know how to use it. We're going to go from decimal equivalent to angles and angles to the decimal equivalents. So when you're looking at a problem like this, you want to go for what you know. And what do we know? Well, when we look at this, the first thing that we know is we've got several numbers here. We've got a radius here of 3 inches, 520 thousandths. We have a height here of 1 inch, 125 thousandths. We have a length here of 2 inches, 273 thousandths, and we have a height here of 2 inches, 500 thousandths. Now this isn't drawn real well, this radius here, in that it's hard to tell where it's really related to or what it's linked to as far as the center point, but you see this crosshair mark down here. And this crosshair mark actually does tell you that that is the center point for this radius. So let's take a look at this and let's go ahead and fill this in. So we know that we've got from the center point out to here, how much? 3 inches, 520 thousandths, right? That's what this is arced to. You also know that you've got from the center point out to here of how much? Again, the 3 inches, 520 thousandths. Now, what you want to do is you know that you can't solve anything unless in trig, well you could, but we'd have to use obtuse triangles and so on, but let's make it as easy on ourselves as we can and solve only for 90-degree angles. So to do that, I'm going to take this line here, connect it up to this here, and you can do that. And does that give you 90 degrees anywhere? Absolutely not. Here's the reason why you know that. A hypotenuse of an angle, or radius of an angle, is almost 100% of the time a hypotenuse, okay? A radius of an angle, or I shouldn't say radius of an angle, a radius on a part is almost 100% of the time the hypotenuse. So what is directly across from the hypotenuse? Well, we've gone through this several times, and we know that that's going to be the 90 degrees. So if this is the hypotenuse here, you're going to have a 90 degrees here. You'll also have a 90 degrees here. Okay? This is just a bisected angle. So basically, what we have on this angle here, going along like this, we're going to have the same over here. We've just taken this and we've bisected it. Now, can I solve for this distance here? Not yet, I can't. But there's going to be a way to be able to figure that out. And how are we going to do that? Well, I'm going to change the color of my pen. And it's, by the way, it's a good idea to have different colored pens. They help you to understand this stuff a little bit better because it helps you to keep things in place. So what if we took this here, this height here, and we drew it straight across, this length, this line straight across, okay? What I'm going to want to do here is solve for this surface from here to here. Why? Because that gives me this 90 degrees inside here, okay? This gives me this right angle triangle. 90 degrees right inside here, which creates this right angle triangle. Now, I can't do that where I'm at right now. I don't have enough information, but I know that I have 1 inch, 125 thousandths from here of up to here. That's straight up in standard, okay? If I took this 2 inches 500 thousandths and I subtracted this 1 inch 125, that would tell me what the distance is from here to here. And if I bring this straight across, I can now go a squared plus b squared will equal c squared, which gives me this total length here. All we're doing on this stuff is trying to find 90-degree planes. So let's go ahead and sketch that in there. Okay, so I've got this kind of broken down here. I also put my trig functions up here because I know I'm going to need them. You should always write these down on a piece of paper. Keep them somewhere, okay? In instances like this, it's always good to have these so that you know what you're going to be referring to. Now remember, we've gone over this before. What are these? Well, the one on the top, the function on the top is the one that you're looking for. The function on the bottom is the one that you have. So in this sense, how do you know which one goes to which? Oh, hell, another hour of arithmetic. The sine, the cosine, and the tangent. Okay? So, oh, hell, another hour of arithmetic. Sine, that's the first function on your calculator. Reading from left to right. The second function is the cosine and the tangent. We're not going to have to use the secondary functions, which are the cosecant, the secant, and the cotangent. We're going to just use these. And there's ways to work around using the secondary functions so that you only have to use these. So, okay, so let's go ahead and take a look at this now. We know that we have a height here of 2 inches 500 thousandths. So let's just go ahead and drop that in there. Let's go ahead and plug in 2.5. I don't want to put this too close to this stuff because we're not using trig yet. Okay, 2 inches 5 minus 1 inch 125 thousandths. That's going to give us this green size. And I'm going to change my pen color to green so that I can get this size over here and you remember where it's at, or what the number is referring to. Okay, so when you do that, you're going to come up with 1 inch 375 thousandths. So I'm going to drop that right in there. Now you have two surfaces. You have, or I shouldn't say you have two surfaces. You have this surface here, and you have this surface here, which means you have two lengths. So you have the 1 inch 375 thousandths, and you have the 2 inches 273 thousandths. What we want to do is we want to solve for this angle right here, okay? Coming off of this green angle, and that's why it's in colors. Okay, so here's my green angle right here. Select that, okay? And I'm going to solve for this. So what is it? What am I looking for? Because I know what this surface is here, I know this is going to be adjacent because it's next to the angle that I'm looking for. So the 1 inch 375 is going to be the adjacent. And the one down here is going to be the opposite side, okay? It's going to be the opposite side over here. Do any of these work for that? Well, you have to have an adjacent and an opposite in both the same functions in order to make that work. We have an adjacent here. It's on the bottom, but we have an adjacent. And we have an opposite here. It's on the top. So that most likely, I should say the opposite is on the top. So that would most likely work, okay? So this function right here, the tangent, is what we're going to use. All right, now I'm going to convert back to black, just so that it's easier to see when I go to write this out. All right, so the one side, the opposite side, okay, we're drawing this down to here. Okay, keep in mind I'm taking it from this side here. That's going to be 2.273. Remember, you have to put this just the way that you see this. So the opposite side equals 2.273. Okay, it's got a line on it just like that. Now we're going to plug in the adjacent side. The adjacent side equals 1 inch 375 thousandths. And if you use this, you're going to be using the tangent, or you're going to be solving for the tangent. Now, this is going to give you the decimal equivalent of the tangent. So let's go ahead and do the math on that. So when we do that, 2.273 divided by 1.375 equals 1 inch, 653 and 9/10. Remember now, that's going to solve for our tangent. So what do we want to do? We want to hit our invert key, and I've made this look kind of like a calculator key here. That box only means that that's a calculator key. So you hit your invert key or your second key if that's what you have, if you don't have an invert key, but you should have a key that says INV or a key that says second, a 2 and an ND. And then hit your tangent key. And you're going to come up with 58.8291 degrees, decimal degrees. Remember, that's not in degrees, minutes, and seconds, and there is no 82 seconds or minutes or anything, nor is there 91 seconds or minutes. It has to be less than 60. So you know you're in degrees, decimal degrees. Okay? So that's what that angle is right there. All right, now what are we going to go for? Well, if we know what this is here, now we've got this side here, and we've got this angle. So we've got this side, and this angle. We can solve for this here. Am I going to need that? Yeah, you're going to say, come on, Ken, do I really need to figure that out? Yeah, you know what? You always want to go for everything that you can possibly solve for. Why? Because step by step by step, it's going to help you to fill in the paper. It's going to give you numbers that you don't know that you had before. Okay? So we know that we've got 58 degrees, 829.1 decimal degrees. And we know that we've got a distance here of 1 inch, 375, and we have a distance here of 2.273. I'm looking for the hypotenuse, okay? None of these, the one on the top is the one you're looking for, the one on the bottom is the one that you have. None of these here have the hypotenuse at the top of this function here, do they? No. Do any of these have the function at the bottom? Well, yeah, this one here does, and this one does here. That's the hypotenuse. So what if you went and you just solved for, let me get this color back here, this angle right here. How are you going to do that? And why am I going to do that? I don't want to use my secondary keys. Okay? So I believe that if I solve for this angle right here, now I've got a hypotenuse that's still the unknown, and the unknown has to be at the top, and you have a side over here, which is a known, but it has to be at the bottom of this function. So that's not going to work either. So how am I going to solve for this hypotenuse without going to the secondary functions? Remember, I told you most likely you're not going to have to. Well, what if you did this? What if you went a squared plus b squared equals c squared? Why not? That'll work. So let's take a look at this. A squared, simple geometry, plus b squared equals c squared. Let's plug in our numbers now. A squared, which one of these sides do you want to be a? It doesn't matter. Let's just plug in the 1.375, okay? Write these down. Don't forget to put the square here at the top. Plus b squared. Make that a better looking 2.273. That will equal c squared, right? Don't forget to put the squares up there. Work it all the way out. Okay, now work these numbers out. So when you do that, you get 1 inch, 890 and 6/10. The square's gone because that's what you've already done. This is this squared. Plus 5.1665. The square is gone. This thing here is gone because you've gone ahead and done that. Equals c squared. Now we're going to take this and we're going to add them together, and we're going to come up with the square root, because remember, in order to get this square to become just c in itself, you have to use the opposite of square to take this and bring this to this side of the equal sign, and that's going to be the opposite of square is the square root. Okay? So when we work it all the way out, what we have is we know that we've got the hypotenuse here, okay? And we had one of the sides, whichever side you would want to use, be it that you want to use the opposite side, or I should say the opposite side, which is down here, or the adjacent side. You're going to come up with 58 degrees, 58.8291 degrees in decimal degrees. Okay, now I changed the colors on this just so that you can see it a little bit better because it was starting to get a little bit busy and we had a whole bunch of numbers up here. So again, we got this one by taking this length and taking this length and going a squared plus b, a squared plus b squared equals c squared. Now we have a hypotenuse, we have a adjacent side, and we have an opposite side, and we have the angle, okay? Got the angle by what? You have two sides. You have an adjacent side, and you have an opposite side, okay? Adjacent side, the adjacent's on the bottom, opposite's on the top. You're going to use the tangent. When you get that far, you're going to break that all the way out. You're going to come up with 58.8291 degrees, decimal degrees. Leave it like that. Then what we're going to do is we're going to bisect this distance here. We know that we've got 2.6565 divided by 2 is going to give you 1 inch, 328 3/10. That's the distance from here to here. Do we need that? I don't know. Put it in there. Maybe you do, maybe you don't. It's going to be the same distance from here to here. All right. Now what are you looking for? We don't have anything yet that we were looking for as far as finding x or finding y, right? So what do we have to do? Well, we don't have a lot to work with, but you do have this. If I took this and I drew a line straight across, let me just change the colors of my pen here. If I drew a line, well, let me draw a line straight down first. I'm going to draw a line from this. Whoops, I didn't want to do an arrow, but I can. I can bring this right down here like that, okay? And I'm going to change this to a line. And I'm going to draw this line straight across, okay? So I drew this line straight down, and I drew this line straight across. What does that tell me? Well, I'm going to use this arrow here as my 90 degrees because that's basically what it's going to be here in this corner. We're going to have a 90 degrees coming down here like this and like that. And if I took this and I drew it straight down, I'm going to share this line here with this other green line here. I'm going to draw this straight down. Okay. Do I know what this distance is from here, up here, to down here? Of course I do. I know that it's the 3 inches, 520 thousandths. That was the radius. Do I know anything else about this? Well, you know, not really, except that if I would go back to this angle here, and I'm going to just go over this, and we'll make this color here. It's going to be a little bit different. If I take this, bring this down here like this, bring this like this, and bring this over here like this. Okay, I'm kind of going over the other ones, but I'm not going straight so that you can kind of see it. Okay, I don't want to use a straight line. Here's my 90 degrees here. Do I have enough information to solve for this angle from here all the way over to here? I sure do. How? I have this. That's the opposite, or that's the adjacent side, and I have this hypotenuse, which is the 3 inches to 520 thousandths. So I've got that 3 inches. 520 here. You're going to say, okay, Ken, so what good does that do me? Well, and make sure you know that that's a 5. That's a 5. What good does that do me? Well, it's this. If I could solve for this angle inside here, and I subtract this angle inside here, that would tell me what this little angle is inside here, wouldn't it? And if that tells me what this angle is inside here, this small angle, do I have enough information to solve for this line down here? I sure do, because it's an opposite side and I have a hypotenuse going all the way up here. Okay? I hope I didn't lose you on that, but we're going to go ahead and we're going to work this through. So I'm going to make this a little bit thicker so you can see how this goes. I don't want you to forget that this green line here is our big angle. So give me a second to clean this up a little bit. So here's what I have. I have the adjacent side, which is 1 inch, 328 3/10. That's this here, okay? And I have the hypotenuse that's 3 inches, 520 thousandths from here to here. So I'm going to use the cosine of this when I figure this out. So this is just division. So let's go ahead and figure that out. So when you do this division here, you're going to get 377 3/10. You can carry that 5 in there if you want. Then hit your invert key and your cosine key. And that's going to tell you what this angle is here. And this angle here is going to be 67.829 8/10. Don't forget that's degrees and decimal degrees. Okay, 829 8/10. Now if I take the 67.8298 and I subtract the 58.8291, that's a 9, not a 5. Okay, 9. I'm going to get this small angle inside here. Okay, let's go ahead and do that. And don't worry if you're a few tenths off, that's okay. I mean, it really doesn't matter. You should get anywhere between 9 inches, 1/1000th or something like that, and 9 inches and 7/10, somewhere around there, okay? And all it is a matter of carrying these numbers all the way out. If you have a calculator that can store more than one function, that's great, because then you can hit your store and recall and so on. But this is close enough. It's going to get us close enough. So now we know what this very, very small angle is going to be. I'm going to sketch this in. I'm going to sketch this in, I think in black, because then you're going to be able to see it better. Okay, so that's what we're looking at now. Now, what do you have here? Well, we can now solve for y, and we can solve for x. X is this distance right here. Okay, it's kind of covered up there, but you can see that that's what that is. That's where we had it over there. So this is x. How are you going to do that? Well, you have an angle. You have a hypotenuse. So what are you looking for? The one on the top is the one you're looking for. The one on the bottom is the one that you have. Okay, so we're going to look for what? So when you do that, you know that you've got division over here. You want to isolate just for the opposite side. You want to get this just all by itself. So if this is division, you have to move this to the equal sign, or on the other side of the equal sign. If this is division, you have to use opposite of division, which is multiplication. Take 3 inches, 520 thousandths, times 1 inch, I mean not 1 inch, 156 4/10, and that's going to give you 5505. So this distance down here is going to be 5505. Now, can you solve for y? Well, of course you can, because if you know what this is here all the way up, that tells you what the leg here is, and then you take that and you subtract the 2 inches 500 thousandths from it, and that'll tell you what's left over, because you've got this total length here, okay? How can you get that? Well, you can go c squared minus b squared equals a squared. That tells you what this whole leg is here. Or you could look for your adjacent side. Okay, this is going to be adjacent here. And you have a hypotenuse, so you could use the cosine for this one. And you could come up with this leg here. That leg, when you figure it out, is going to be, let me do it real quick. I come up with that distance as being 3 inches, 476 6/10. Then I'm going to take that and I'm going to subtract the 2 inches, 500 thousandths from it to get the length of A, okay, to get this leg here. So when you do it all the way out, these are going to be your answers. Now keep in mind, you could be plus or minus a couple tenths on either one of these things. It's just a matter of carrying out your numbers all the way out or not. This could be 9.7666. It could be 976 and 5 tenths. This could be 550 and 7 tenths. Again, pick the answer that's the closest, that's in your book, that's in the test, and you'll do fine as long as you get it somewhere close to this. Hope this helps, and we'll see you on the next one.